Today's topics, we are going to focus on the AI mode in search. We are going to glimpse into how a multi-agent system can work together to answer the complex questions in search. And this presentation is developed based on a recently released KDD paper on multi-agent proactive information seeking from Baidu. So the challenges is in the search, not all questions are equal, right? So some questions are easy query and some are more complicated. So the search system actually face many different types of questions with also varying levels of complexities. And then we, like as a prerequisite, I think it's also important to understand what are these complexities of these questions in a search. And then we can better understand why a more advanced multi-agent systems is needed. There can be like a different question type, right? Factoid questions, which are like a simple single answer Q&As, like what is the capital of France? It's like very straightforward answer to that. Or it can be non-factoid questions, which are more complicated, right? And also it usually doesn't have like a one questions that you can easily say, oh, this is the correct answer, and usually it requires a more comprehensive response, such as what are the advantages and disadvantages of electric vehicles, right? So the factoid questions are simple and single Q&A pairs, basically, right? So it's a single fact answer, and it's very easy to verify whether it is correct or incorrect. And the answer is usually very concise, right? It's typically short, just a few words or sentence. And you don't need to rewrite the answer. So no synthesis is required. You don't need to combine information from multiple sources to generate the final response. Like who is the CEO? What is the capital? So all of these are factoid, simple questions. And then when we move to non-factoid questions, it's usually like multidimensional, right? So usually the response requires multiple aspects, perspectives, or dimensions to that queries. And synthesis usually is required. You need to pull information from multiple articles, web pages, or different sources in order to answer the question in a comprehensive way, right? So yeah, so the answers usually are long and detailed rather than just a few words. And also it's context dependent. So it's very hard to define the correctness of that answer. And usually it's based on the context and from what perspective the system is answering that question. So why are these type of questions challenging for traditional systems? Because traditional retrieval systems struggle with this non-factoid questions because it's not like a single retrieval operation. The system usually needs to perform multiple search and also should evaluate what information is most relevant and useful from different sources. And then it's going to synthesize the findings, right, into one coherent answer. So this requires a more proactive, iterative information seeking process than one-time RAG-based or one-time passive retrieval type of problem. Yeah. So we kind of know, okay, what are the difference between factoid and non-factoid? And we also see that the static search or the traditional RAG cannot handle this dynamic nature of non-factoid questions efficiently, right? Because the traditional RAG usually is more on the fixed search patterns that cannot easily adapt to the evolving information that requires, say, multiple search in a proactive way. And it also lacks of systematic multi-source integrations, right? We are looking to coordinate information gathering from multiple searches and multiple sources and perspectives. And usually, like most RAG can kind of just perform one search and then just generate the answer based on the retrieved content. But this missed the opportunities of iterative refinement and also deeper thinking and explorations in the dynamic nature of this type of non-factoid questions. Yeah, and this also usually lack the proactive exploration, right? Traditional RAG usually wait for the users to say, what is the query or what is the question. Instead of the system can proactively ask the questions or create new queries in order to fulfill the gap or to get more comprehensive content from various sources. So these are all the capabilities that the traditional RAG systems lack. And so that's all the context and background, and that gave birth of why more advanced agentic workflow or system is needed to answer complex non-factoid questions. And this paper is also called PASS. So PASS stands for Proactive Agent-Driven Search System. So maybe let's look at first what kind of the overall components in the PASS system. Right? So the user first asks to the system a complex question. So this initial question is from the user, such as what is the vicarious trauma and how to cope with it. And then there is like a multi-agent system, right? So there is a reviewer or analyzer to understand what is the user intention, right? So the user intention here say, oh, wants to understand the definition of this phrase and also want to understand the practical ways to cope with it. So this is more like a user intention agent. And then it goes to the navigator agent, which is also the planner part, to based on the user query and intention analysis, it's going to figure out the execution plan, right? So this is like a high-level list of to-do list for the system to figure out how can I perform the task more like strategically at a higher level. And then all this information is going to the seeker or the executor. So the seeker is kind of equipped with the tools to perform the web search and retrieve the content from the website. And for each of the tasks, so you see there are 4 tasks here. And then for each of the tasks, it's going to generate a set of search queries. So basically, it can further develop the task to a set of search queries for searches, right? So within each task, there are like say 3 queries to execute, and then it's going to retrieve say the top content from the search engine, and then it's also going to synthesize to complete like what is the task summary to summarize the information from the retriever. So this can be all executed as it can be executed in parallel, corresponding to each of the tasks. And then in the end, there will be a writer, right? So writer is kind of taking all the information here and then figure out, okay, how can I generate that final response as a coherent message to the user? And then the writer will be responsible for writing the final response, taking all the response from the individual seekers. Yeah, so basically this is a high level. Oh, there's also a reader here, which I will also provide a little bit more detail about like the reader as a critic and also as some to make sure that the content is relevant and comprehensive. Yeah. And then the next few slides, I am going to walk into each of the agent, and I will also directly show the prompt they use. I think a very good part of this paper is they disclose the full set of prompts instructions they have designed for each agent, and also what is the thinking principle they have developed for the agents. So let's look into each agent. So the first agent is a reviewer agent. So the reviewer agent is to understand the user intention, right? So it's just kind of understand, okay, what the user really wants to get. For example, here, if the question is like this, and then the reviewer is going to understand, okay, what is the question type? The type can be whether it is the definition, right? So you just want to understand the definition, or it's looking for a solution for some problem. And then what are the key concepts? So the key concept, kind of like the keywords from the question. And then what is the information it may be helpful to answer that question, right? So this is more like a question analysis. And then this is the prompt. So the prompt is usually like formatted into instructions, input, and output. So the instruction is like you define the role, right? So you are the reviewer agent, and then you want to analyze the user questions, right? You want to understand the question type, logical structures, motivations, and any information that you think may be needed to answer this question. And also the prompt should also define the format of the output, right? To make sure the analysis is input into this question analysis brackets. And then end the final output with the end of sentence token. Yeah. And then the input is basically the user query, the user question as input, and then this is the output. So this is kind of the prompt for the reviewer agent. And again, this is just to do the initial analysis to understand the user intention. The second agent is a navigator agent, or I usually also call it planner, right? So the planning agent. So the responsibility of this agent is to receive the question or the user intention analysis from the reviewer agent, and then further decompose it or come up with the task, the plan, right? A list of tasks to execute at high level. So basically, it's trying to break down the user question or intentions into a more structured subtask for retrieval. Same questions over here, right? And then the navigator output is kind of going to create a list of tasks, like do a research and define this, and then identify what, like profession, situation, institutes, etc. Right? And then perform these explorations for the strategies, and then finally investigate about the systems, and then also do some comparisons with related symptoms like that. And then in terms of the prompt, it's like the same, right? So you put as the instruction, input, and output. And then instruction, you define the role, and then you also tell, okay, the final output is like a list of subtasks input into the task list. And also you may put also some upper limit to say, okay, provide no more than 5 subtasks, like as a high level plan. And the input will be the initial user questions, and it also can be the user intention analysis from the reviewer as the input to the navigator agent. Okay. So once the high-level plan is figured out, and right now it's more for the execution, and it's going to generate the queries for each of the tasks. Say the navigator agent generate 4 tasks, right? And then over here, the seeker agent is just going to take 1 task. So the seeker agent is going to take, say, 1 task, one task from navigator, and it's going to generate the fine-grained queries to the search engines. Right, so this is a query 1, query 2, etc., etc. And then this is the instructions. And you see that the inputs are kind of growing longer and longer because the inputs is also kind of providing all the context information, all the prior the agents, the outputs from the previous agents, and also any historical queries and results it has already received. Right, so this is kind of, you see the input is going to be longer and longer. And the instruction here, yeah, so you start with the role definition, right? So you are seeker agent, more on the execution, and then rely on the input, like including, so you can introduce what is the inputs to this agent, including the user questions, the task list, and also you can provide it the historical queries. What are the tools you can is permitted to run? So usually it's the web search, like the tool, right? So you can do a tool web search to perform a tool web search. And then you can also kind of grab the response and then put it into the action output, like say the output from the tool invoking. And then, yeah, so you should also output a summary within certain character limit. Yeah, between this action output limit. Yeah, so this is kind of the instruction for the seeker agent, so that the seeker agent can derive the list of queries to execute from 1 task from the navigator output list, and then it's going to execute the search queries using the web search tool, and then summarize the response from the queries search. Okay, so, and then that's the execution. And then we also need a critic. So that's usually how a multi-agent system is defined. So usually to improve the qualities and to make sure that the final response is coherent and to the point as much as possible. So usually there's a critic agent. Well, in this paper, they call it a reader agent. So this is the quality control gate of this system. So this agent is going to review all the retrieved documents or web pages and only select the most relevant and most useful informations based on the retrieve list, right? So for example, based on all the execution or web pages, it's the search engine returns, say, in the end, like 10, say 10 top 10 like web pages. And then the reader agent is going to analyze which of this page it will be most beneficial to this question. And also, because the top 10, there may be also duplicates, right? Let's say the second page is also relevant, but or sometimes it's like not specific or not informative. Let's say this is also relevant, but it has high overlap with the first one, then it's also not that useful, right? So the responsibility of the reader agent is to look at the full list and to decide, okay, how can I select a comprehensive subset of this list so that I can to reflect both the complete list and also make sure that the list also, has the diversity there, can kind of represent different viewpoints or perspectives when possible, right? So this is more like as a critic and able to aggregate all the search results to make sure that they serve the same purpose and also diversified enough to provide the final comprehensive answer. So this is kind of the instruction to the reader agent, right? And yeah, so basically the role definition and what is the responsibility of this agent, what is the format that you expect the agent to provide in the output. Yeah, so this is the critic part. And say after we get the search queries, after we criticizing the list and then get our final list of web pages or documents retrieved. And then the last step is the writer. The writer, this is the final stage, right? So it's responsible to integrating all the different sources together and then write the final response to the users. So basically, this is more like a synthesis process. The inputs includes all the filtered documents or multi-search query results from different web pages. And then it's going to integrate all this content into a diversified kind of opinion or response to the users. And also it may need to resolve some contradictions in the information. And then the output should be a comprehensive and multifaceted answer that can address all the different dimensions of the answers, right? So this is the narrator or the writer agent, and then this is the role is to based on the provided search results and the task summary, you need to write an accurate and detailed and in-depth and well-rounded final response. Yeah, so it's what's your expectation of the writer agent. And also you need to tell the agent how you want the answer and also if you want the citation there. So if you use the AI mode in Google search, you also see there's on the right-hand side, there's also citation provided along, right? So the writer should, whenever it's write something, it should also provide a citation. Like you can cite the search results with the ID in the brackets, right? And then that list can directly display on the right-hand side along with the final answer. And yeah, so make sure the response is in this format. And then of course, like the inputs is all the kind of previously user questions analysis and also the filtered web retrieved web pages or documents. Another thing I think is very interesting, they also disclose their agent syncing protocol for the LLM. So the agent syncing protocol is kind of like one one prompt that is embedded to every agent to introduce that reasoning, like what is the principles for reasoning, to make sure that the agent can create a quality output and also can make logical thinkings and to mitigate the hallucinations, etc., right? And also to enhance this multi-agent collaboration. So to all the agents, what I showed earlier is the instructions, right? So they frame each agent prompt as instructions. This thinking protocol is put in the middle, and then the inputs, right? So the inputs, which is the user questions, analysis, the retrieved, the output from other agent, etc. So this protocol is the same prompt, but that is inserted to every agent to enhance the reasoning capabilities or guidelines for the agent. And it's a very long. It's in this paper appendix, and it's a very long reasoning principles. But I think it's helpful. So if you are building an agent that also requires this type of reasoning, I think you can look at this to see whether you can use some of these principles, or you can also define your own reasoning principles to put into your agent prompt. I don't need you to read every line, but you see the green highlighted ones, right? So these are the thinking principles for the agent, including thinking before, right? Before and during the response. And the adaptive thinking framework, what are the core thinking? So initial engagement, etc., exploration, discovery process, that and test and verification. And also the quality control, and also more advanced thinking techniques. And what are the essential characteristics of the agent, right? To showing a genuine curiosity and real moments of discovery. And also you may want to put some important reminder there, right? So you want it to be comprehensive, thorough, and distinct from the final response, etc. So you may want to put some very important reminder to the agent, to each of the agent. And also at last, it kind of remind the agent again that the agent must follow this protocol in all languages. It's also interesting to see what's their thinking principles, and this is inserted into the prompt to every agent. Yeah. So that's the agent, and then actually this process is not a sequential process, right? And any multi-agent system is more like a iterative process. So unlike a rack, like you just do a retrieve and then do a write, right? Search and answer cycle. A multi-agent system is usually like it's an iterative loop until the navigator or the planner think, oh, this information is good enough, or I'm not able to detect further gap, and then they can close the loop. Right, so once you search the task, once you evaluate the results, and then the navigator or the planner there is going to access the completeness of the existing results, and then it's going to, if it's able to see any gap or further improvement, the navigator is going to create another list of tasks to kick off the search and reader and writer again, right, to further refine the response. And when this loop will stop, I think is first is well totally up to the navigator, like to say, oh, I think the result is already complete, right? It's good to respond to the users, or you can also set an upper limit kind of iteration, like 3 or 5, depending on how fast you want to respond or how critical this information is to the user. So you may also want to set a system upper limit of how many loops you allow the multi-agent to run. So this is kind of a recap of the full process of how this system answers this complex question. Yes, so it's the same question showing up again. And then you have this 5 agent, like 5 rows of agent, and they are using the GPT-4o as a backend. With a different set of prompts, right? And the dynamic inputs to each agent. And then this is the final response, right? Kind of, well, of course, like displayed here is a summary about, okay, what is this? What is the vicarious trauma definition? Define the concept first. what is affected groups, what are the symptoms, and what are the core coping strategies to handle these symptoms. The next is the cost optimization. I can also imagine when they deploy it directly with the GPT-4o in any search, it's going to blow up the cost very soon. So, so I think, yeah, so the challenges is like, if you just directly use the GPT-4o kind of like LLM or any LLM API, in production, it delivers excellent performance, but it's also expensive. And then they're also looking at any open source model, for example, the Llama 3.1, 8B, like or any open source model, 8 billion parameters open source model, right? So these are more like a cost effective and also can run locally without any API access, especially if you want to have this system, say, just internally for your corporate and you are hesitated about sending the content over API, right? Then you may also want to have a local hosted, lower cost. There's also a bunch of options to choose which size or which capabilities, right? You are considering to choose like which open source model to use. And then, of course, if you just directly use the 8B model, it may not perform very well. So this paper also benchmarked the performance there to say, okay, how about I just use the open source model out of box? What is the performance? And what if I perform the task-specific fine-tuning? What is the performance? And what is the performance gap comparing to I directly use the GPT-4o? Okay. Then what gets fine-tuned? Well, if you think about how many agents here, like 5 agents, yeah, then you have 5 tasks. you have 5 tasks to fine-tune, right? So the first task is the question analysis and intention. I think the beauty of the multi-agent is just decompose the system in a more like each agent has a more specific role, right? And then the fine-tuning kind of also becomes more straightforward and obvious because the input and outputs is kind of more structured comparing to any general Q&As, right? So because you have 5 agents here, and then you should kind of have a fine-tune for each of the agent, right? So the reviewer agent, which is the question analysis and intention understanding. So you can have a fine-tuning just for intention understanding. You can have a task list creation agent, right? So the input output, and then you want to based on the user intention to generate a list of tasks. So this is the planner agent, the fine-tuning. And then you want to generate the queries based on the task, right? Per task, given one task, what are the queries to generate? So this is another input output fine-tuning, et cetera, et cetera. So basically it's kind of like you need to fine-tune the model per agent, per task. Yeah, so I think this is what they disclosed, and then I don't think they have fully disclosed how the exactly training data looks like for each of the tasks, but I think it's more like the logging, right? So you should log the input output for each agent when you are running it in action to accumulate some input and output pairs for you. And then you have a better idea about what are the data format and how can you debug it and fine-tune it with the open source model. Yeah, so another aspect I really like the paper is they develop a very large sections on the rigorous evaluation of this multi-agent system. Because usually when I see people say, oh, the multi-agent system works, and then works in what sense, right? So we need to develop evaluation metrics to say how the multi-agent system is performing, especially to the baselines, right? So why not just do one LLM call? What is the point of building a multi-agent system instead of just do one LLM call? So basically, we need to define what are the data sets we want to benchmark, right? So they choose this RAG, kind of the RAG system benchmark data sets. This track, I think they just released a 2025 version as well, and also this natural question data set. And then the baselines can be just direct LLM call, right? Just directly ask the LLM like what's the answer to that, and then there's also traditional RAG and also enhanced more advanced RAG. And then what is the metrics? So they also propose an evaluation, kind of the nugget-based evaluation. I'm going to introduce next. And then the LLM backends, yes, so they use the GPT-4o as the biggest kind of the API call backend. They also benchmark it with the Llama 3 8B model. And then before we understand the metrics, let's first also look at the baseline. So what is this multi-agent compared against, right? So it's going to compare against the direct LLM. So there's no retrieval, just based on the pre-trained knowledge of the LLM. And then let's see what's the response there. So this is a direct LLM. There's a traditional RAG. Traditional RAG is just like a single shot, right? So you just do one retrieval, provided in the context, and then ask the LLM to generate the response. So this is traditional. There's also enhanced RAG, like this self-reflective retrieval. So this is more to allow the model to dynamically incorporate relevant information from external source and able to perform critics on the generated response with some self-reflection in the RAG. And also there's a refined query RAG. So this is also another trick how you can improve the RAG by rewriting the queries in a more relevant sense so that the final response can also be more relevant. Yeah, so this is our kind of like all the baselines that this multi-agent is going to compare against. And then in terms of the metric, so they propose the nugget-based evaluation to more focus on the completeness of the answer, right? So whether all the critical information has been captured in the response. And of course, to evaluate it, you need human annotators. Yeah, for sure, someone may say, well, why not just use the LLM as annotators? Well, the LLM can be also best in evaluating itself, right? So usually the most objective, somewhat like evaluation will still require the human annotators in some sense, right? To decide, okay, whether the final response is comprehensive enough or is helpful enough. And then the human annotators will identify all the nuggets in the system. So what is a nugget mean? So the nugget is more like what are the key concept of this question. For example, yes, the same question here, right? And then there are vital nugget and okay nugget. The vital nugget, which is, for example, the definition is vital, right? It doesn't make sense at all if the final response miss providing the definition of the key concept. So this is a vital, it cannot be missed. And then there are, and also this is a vital, right? How to cope with this coping strategies. So this is also vital. The OK nuggets is more like supplementary information that you can provide it along with the vital to kind of help provide a more comprehensive like message, right, about the professionals, about the coping strategies with the peer support group, etc., or doing mindfulness and self-care, right? So these are more extensions or supplementary information that can help the users. So basically the human annotators is going to kind of also label the vital and okay nuggets. And of course, I think they have some type of ground truth in the benchmark data sets. So they are going to just categorize like the message into all these nuggets and also classify them as vital and okay nuggets. And then they are going to see, okay, based on the ground truth, how many of these vital and okay nuggets are captured by this multi-agent system, right? So then they develop the total score. So this is the V total, and the O total is from the ground truth, or like say some response provided by a human expert. So this is from the human response. And then this is from the multi-agent system outputs, right? How many vital information and how many okay information from the multi-agent response. And then you want to see from the ground truth, like are the kind of the most human expert outputs. How many of this information are captured by the multi-agent system? So this is a total score. You can also define a score just for the vital just for the vital nuggets, right? So the core definition or the core coping strategies. And then you can also define the weighted metrics for the total score. Like over here is because you may want to put a higher weight on the vital nuggets. Yeah, so all of this score is going to be vary 0 to 1. And if there's a system with a high vital score, so basically like the vital information are all captured, but with a low total score, meaning that it may just capture the core information, but misses the supplementary details in the final response. Yeah. Okay, so I think that's the baselines and the metrics about how it's going to be evaluated. So then they report the performance on the benchmark dataset. So this is with the GPT-4o, the total score, vital score, and the weighted score, right? And then they also have some strict. So they also have some strict. I think this is just for human annotator, whether you want to perform a more stricter evaluation or not. So they also have a strict total score, strict vital score, and a strict weighted score. It's just a different level of evaluation criteria for the human annotators. And then you have like a 2 benchmark data sets, and then across like a set of like a baseline method, right? Without RAG, it's like direct LLM call. And then you will see the performance of how many of the core or the important nuggets are captured by the system. And actually, to my surprise, without RAG, it's actually perform better for this data set in the benchmark. So without RAG, the performance for the vital is actually a lot better than this normal RAG on this data set. So I would say this data set maybe will be more factual checking, right? And the LLM itself may already contain all the information there. And providing the context actually hurt the performance of the performance. Well, this data set is the opposite, right? So this data set, you see there are, like even with the vanilla RAG, it's also showing the improvements over the direct LLM call, which means that this type of benchmarks requiring more dynamic context than the LLM prior kind of pre-trained knowledge cannot capture cover the knowledge in this benchmark data set. But I think the data points shown here is also very interesting to show, like, if that information is already exists in the LLM knowledge, providing this context somehow actually hurts the performance of the output. Anyway, so they want to show that no matter which situation it is, no matter it's already exists in the LLM knowledge or it's like very new to the LLM, this PaaS multi-agent system is able to outperform across all the benchmarks. And is able to capture still, I would say, not at a human expert level, right? So it's still kind of like for vital, it's about like 67% of the vital information can be directly generated by this multi-agent system, comparing to a human expert who already know these symptoms or disease, is able to provide a more comprehensive information comparing to this multi-agent system. But I think this may be already sufficient, I think, for any human who is not in this domain, right? So this is already providing this much like useful information for any human queries. So they also show the fine-tuned performance, right? So they show that the fine-tuned performance is able to achieve 93% of the GPT-4o performance. So this is the past performance with the GPT-4o as the background, as the backend. And then this is the pass with the Llama 3, 8B, without supervised fine-tuning. Yes, then without supervised fine-tuning, I think the performance is going to be lower, but actually it's not also that bad. It's still able to provide in some like useful information, like still able to capture like on average 44 kind of, actually if you compare this is still like in terms of the core, the vital is still comparable. So on this data set and on this is, so on this with the fine tuning, you are able to improve the performance for this open source model. Yeah, so basically they show that with the supervised fine tuning, it's able to improve the performance over the 8 billion model, and then it's able to get to roughly around 90% performance of the GPT-4 performance. Yeah, so usually it's like a trade-off of the performance and the fine tuning. And I do think with right now, because they are using Llama 3, and right now with a more powerful open source model, right, recently released, and also with the better fine tuning techniques, I think we are able to match with the big model performance on the seen cases. And of course, on the unseen or like more general unseen cases, the big model may still win over there. And then they also did some ablation studies, right, to see which agent is the most important to the multi-agent system. So, so basically, this is a supervised fine-tuning path. This is the performance score, right? Total, vital, and weightage. And then they will see, okay, without the reviewer agent, without the user intention analyst, or without the planner agent, or without the reader or the critic agent, what is the corresponding performance? And the bigger the drop, then the more important the corresponding agent is, right? So if you move this row out, if the performance drops a lot, it means that the role is very important to the multi-agent system. So if you look at that, then you will see that, so I think the navigator agent is the most important, right? So the navigator agent is basically the planner agent who create the list of tasks even before running the queries, right? So the planner agent or navigator agent is the most important. And then the reader. So the reader is the critic agent who are going to identify what are the most relevant content by seeing the full list. And then it's going just to retrieve the most relevant and most kind of like deduplicated list of content to the writer, right? So the reader is also important. The least important is the reviewer, which is the user intention agent. So moving it out, it also hurt the performance actually, right? But it's not as much as the planner or the critic. What is more interesting is they actually deploy this system in production and using A/B testing to really see the real-world impact. I think this is also what KDD conference favors, right? So they really want to see the real-world deployment of the agent and to see what is the benefits in production, because previous metrics is all like research metrics or science metrics. What is even more important is the business metrics, right? Like how this, how is this research metrics translated into this business metrics? So why the A/B testing is important and like why the real-world testing is matters, because the academic benchmarks is usually in a controlled environment, while the real-world deployment is real impact, right? So usually the research is research, but the real-world deployment really shows you the business value. And also the production environments may give you additional challenges, right? You may need to handle a lot more diverse user queries, and also you have the latency issues and also the actual user satisfaction with the system, which you cannot like benchmark easily with the existing data sets. And also they run the A/B testing at scale, right, to compare this multi-agent path system versus the traditional, say, RAG-based system, and to see what's the measurable business values and user experience or user satisfactions with this improved multi-agent system in search. Yeah, so the A/B testing, like there will be a control group, the treatment group, right? So that you want to see whether the treatment group can improve or there's a significant improvement over the control group. And the assignment user are going to be randomly assigned, right? So you want to rule out all the other factors that can cause the performance difference. So usually, like, you just randomly select users to be assigned to control group or treatment group. And then you are going to track the metrics, more business metrics at production. So usually in a search system, you kind of track the click-through rate, dwell time, like how long the user stay on that page. They may also perform some additional user satisfaction ratings, etc. And how often the user is going to rewrite the queries, right? So if you do a search and you are not satisfied with the results, you may rewrite the queries again in a short time, in a second or a third time, right? And also they want to make sure that the results are statistically significant with a large sample size. Yeah, so this is a final business improvement, right? In terms of the user engagement and satisfaction. So if you are preparing for ML engineer interview or AI engineer interview, I highly also recommend that you familiarize with the business metrics, right? And you should be very familiar with how to relate the ML metrics to the business metrics. For example, this is a good set of business metrics for any search system, right? Like the change query rate, how often the user is going to change the query, the first position satisfaction rate, right? So this is more related to the search engine, the ranking system, right? Well, what is the satisfaction rate over the first few links? What are the click-through rate? And then what are the average dwell time? Like how long the user is going to click into the page and stay long enough on that page. And also the page views, right? Say you are going to provide a list of links as a reference in your response, and how long the users are going to kind of clicks into the views in the content you provided, and also how long the users actually stay to read through the content that this AI mode provided to the agent, right? So this is like kind of, yeah, so the dwell time actually increased a lot, like by almost 3%. Which means that the content is interesting and inspiring to the users, and the users usually stay longer to read through the content longer, right? With the improved ML performance. And all of these values are, they also do a statistical testing to make sure the p-value is smaller than 0.05, and also over like a 20K unique user questions in the production. Oh, and do not think this is small. So usually in a very large scalable system, if you can improve it by 0.1% or 0.5%, like 0.5%, it's already a big revenue generation for a production system at scale. So if you can improve it by 3%, it's already a huge improvement in terms of the business metrics. Yeah. In terms of the key takeaway of the past multi-agent system, right? So I think this is just to give you some idea behind what is behind the AI mode in search, right? So this is just like a multi-agent system about how it's able to like understand user intention, to create a high-level plan, to generate the queries, the sub-queries to execute it, and perform the critique, and then synthesize all the information into one final response with the reference to the regional links, right? And then, so basically this is just, I think it's like a first paper that I see that kind of give you a very full kind of glimpse into behind, especially they have released the full prompts, right, for each agent. I think this prompt can be also reused and also readapted to any agent you want to build, right? So you can adapt those to your use cases. And also this paper also sets a very good example of how you may want to further optimize the cost while model task-specific fine-tuning, and also how to actually evaluate the multi-agent systems with all these ML metrics and business metrics. And also, I think it shows some exciting future directions for across the domains, right? So it's not just for search, because the search itself is just so universal, can be applied to any domain, right? It can be applied to customer service, healthcare, education, or research, right? So the search is the kind of like a core service that can be used to support any domains or even like IT queries, right? I think we also have one about the IT issues right? So basically the search is kind of like a very universal functionalities and service that can support all different kinds of practical applications. And then this multi-agent system and the prompts can also be adapted to different domains. In terms of the future directions, the also mentioned about the multimodal, right? Yeah, and the multimodal is still the hottest research right now in terms of the images, videos, right? All the different modalities and how you can efficiently incorporate them, because the images or videos are going to take a lot more tokens comparing to text. So basically, like how you can handle this non-text tokens even more efficiently, right? Just on top of text. And then how can you do more personalization, because usually search is also personalized. So how can you incorporate the user taste, the user background into the search engine? And about the efficiency and scalability, right? So there's right now I see like when the Bedrock or no, when the LLM is released and everyone is rushing into using the LLM and do all kind of API call, and then they realize it's too expensive. And then right now it's like, okay, the top strategy also becomes, okay, how can we further reduce the cost, right, for this agent system, like so that, and also improve the latencies and how we can use a small language model or small language vision model to better balance the trade-off between the performance and cost. And the last is also the evaluation, right? So the evaluation is always the key, and also I would say one of the biggest bottleneck to actually roll out any multi-agent in production. Like you need to make sure that the multi-agent is actually behaving to the expectation, right? So that it can earn the trust rather than lose the trust from the customers. So I think all of this are like very interesting, like research about how we can further develop a more efficient and trust-earning multi-agent systems in any domain.